The goal with this simple little video is to help you get started with Pre-Lab 3. Sometimes students have trouble getting started. The instructions are all in the lab manual, but I thought I'd go through the general process for you to help you. You can't do Pre-Lab 3 without filling in this table here, and so it is critical for you to get that. But before I begin, the goal of this exercise is to present to you a simple model of population growth, where you start out with a single individual. And in our simple model here, our first individual is this white circle here labeled first individual. And the idea is to see how this population grows through time, given that our individual will give birth to one offspring at every time period. So that's one of the rules we instituted within this model. But also realizing after this individual, or after each individual lives for 3 time periods, it will die at the 4th time period, and that's what these X's represent, are deaths. So given that populations have both births and deaths, can we have some understanding how this population will grow? How quickly or how slowly will it grow through time? And then questions in the pre-lab will get you thinking about density-dependent, density-independent growth, and hopefully, by the time you get through the pre-lab, you will be able to recognize this as either a model of density-independent or a model of density-dependent growth. But backing up here, let me just work through this with you so you kind of know what we're trying to get at here. So again, like I was saying, we're starting out with a single individual, and by definition, each individual lives for 3 time periods and dies at the 4th time period. The different colors here are just representing the single individual as it ages. So we start as a white individual, becomes yellowish, becomes an orangish color. Then again, like I was saying, the red X is death. And that's true for all the individuals throughout the model here. The second rule is at every time period, each individual will give birth to one individual. So that's what these arrows are trying to track here, are the births, and trying to track the offspring of each individual. So again, working backwards, starting with our first individual here, this white circle here. Again, by definition, he gives birth to one individual. We can track that arrow to this white circle right here, which is the first offspring of our starting individual. We also know that by definition, this individual will give birth at every time period it's alive, and so we can track its first offspring just by following this arrow out here and finding the white circle down here, and so on. So the first offspring of this individual will be following this arrow out and be this white circle here. So every time you have a white circle, that indicates a birth. But then we know what this individual ages, that really happens. So the second time period the individual is alive, we've marked that as yellow. And so to track the second offspring and all the offspring of the second offspring, we want to follow the arrow but down into this set of circles right here. So this represents the offspring of the second offspring of our first individual. Does that make sense? So backing up, let me say it in a different way. So our first offspring, at the second time period it's alive, it gives birth. Its second offspring is depicted down here. Its birth is this white circle. And then we can follow the offspring of our second offspring from the first individual. So again, the first birth from this individual is tracked with the arrow out to here, just like we've done before. The second offspring of this individual is tracked following that arrow here, and the third offspring can be tracked here, and so on. So the arrows are just tracking where the offspring are occurring. Then we also know that this individual will live 3 time periods, so the 3rd time period it also gives birth. So the 3rd offspring is just tracked by following this individual down to here and looking in this set of circles down here, so you can track the offspring of the 3rd offspring from our starting individual. Hopefully that makes sense. Okay, so backing up here, so as you're working through this, what you also want to consider is how many individuals are being added to the population for every time period. So over here on the right hand side of the grid, we have 2 designations here. We have one that says time, T0, T1, T2, T3, and so on. Then this thing called N sub T here. And N refers to population size, and the T refers to the population size at a particular time period. We're generally going to start out with T0, which is our starting time period. it's our first time period, but it's called T0 because that's the starting point. And the population size at our first time period is 1. And we can figure that out by going way back here and seeing we have one individual in this row going all the way across. So our population size at T0 is 1. Again, which makes sense. We started out with a single individual. Then we go to our T1, which is the next time period. And so we want to know what the population size is at that time period. And so it's very easy for us to track that. We just go and follow this row going across and count how many individuals there are. There's our first individual. It's just a little bit older than the offspring of our first individual. So we have 1, 2 individuals. So we go way over here and write 2. Then we do the same thing at T2. We can just go across this row here, count how many circles there are. There's 1, there's 2, there's 3, and we put a 3 in this row right here. And you just do that all the way down here. As you go down, you'll notice some of these rows, you'll start seeing these X's. For example, at T3, our first individual dies. And so we have a death here, so we wouldn't count that as an individual being present. So the population size at that point would be 1, 2, 3, 4. And we put that number in here. So again, we have 4 individuals that are living. We have 1 death here. You would do the same for this group of individuals and the same for this group of individuals. One thing to remember is this T0 represents the same time period as this, which represents the same time period as that. And the same for T1, that's the same time period as that, and that's the same time period as that. And that's important when we're adding all the individuals. So once you fill this in, so you figure out how many individuals are in each one of these time periods, and we have these numbers down here to help you make sure you're on the right track, then you're going to want to fill in this table. We filled in the first row for you in the lab manual, and we filled in T6 for you also, so you're on the right track here. What you want to do here is basically we're going to transfer the numbers here into this table right here, but here we're going to be keeping track of births and deaths in separate columns. So let me back up and explain what's happening here. So we have our time periods here, T0, T1, T2, T3, and so on, just like we have in the tables over here. This T0 is the same T0 as that, and that, and that. They're all the same time period. They're all our starting time period. Births, that's pretty straightforward. How many individuals are born? Deaths, that's straightforward. Again, how many individuals are dead? The births, again, in our table are indicated by the white circles. The deaths are indicated by the red X's here. In sub T here, this value just means the same thing as this value up here. What's our population size at a particular time period? In T minus 1, it's a little bit different nomenclature. That is referring to what is the population size at a previous time period. So in this case here, we really don't have our previous time period since we're defining our starting point at T0. The population size at a previous time period in this case is just going to be 0 because this is where we're starting. We had 1 birth. That birth is indicated by this white circle here. So it could be spontaneous generation, or however you want to imagine a birth happens. But we just have a starting individual. We're just going to call that a birth for now. And again, at T0, we had no deaths. We go through all of our charts here. We have no deaths at T0, and so our population size at T0 was 1. So this number should match that number right there. Going to T1 here, the N sub T minus 1 refers to the population size at the previous time period, and the previous time period relative to T1 is T0. And so the population size at T0 is 1. So this number will then be moved over here. You'd fill in a 1 right here. And that's the population size at the previous time period. And the previous time period relative to T1 is T0. Then you want to count the births. So we go back in our chart, count the births. How many white circles are there at T1? There's 1. Want to take into account T1 down here. There's 0 here and 0 here. So the number of births is 1. How many deaths are there at T1? Again, we go back to T1 up here. There's no X's, no X's, no X's. So there's 0 deaths here. And so the population size at N sub T here is the population size at T1. And so you're going to add this column plus this column, and then you would subtract any deaths. In this case, there's 0 deaths. And so then the population size at T1, or what should be here, should be the value of 2. And then you would just carry this number down to here. Then you go through at T2, figure out how many births there are, how many white circles are there. And you want to take into account all the tables. So again, for example, at T2, there's a white circle here. T2 here, there's a white circle here. But T2 here, there's no white circles. So you want to take into account the births that are happening in all of these little sections here. Add that here, and then you would do the same thing for the deaths. You want to take into account how many deaths are at T2 in this grid, how many deaths are at T2 in this grid, and how many deaths at T2 are in this grid, and you add those together, and that would be the number you would put there here if there are any deaths at this time period. As you go on, you will notice obviously there are going to be deaths. That's going to happen. So we don't have any deaths initially, but you will start seeing deaths, and the pre-lab asks you some questions as to when you start seeing those. These values over here, the lab manual explains what these things mean. It goes through the calculation of density for you. There's some questions related to that. You can't calculate this right now, so you just want to wait for that. This number right here is the population size at the next time period. So n sub t is the population size now. N sub t minus 1, as I said, is the population size at some previous time period. N sub t plus 1 is the population size at the next time period relative to the time period you're interested in for this guy here. It gets confusing, but hopefully it makes sense with a little bit of practice. So here, this 2 comes from the number, comes from right here. So if you recall, we brought this number down here. This is 1. We had 1 birth, 1. We had no deaths, 0. So 1 plus 1 is 2. That was our population size at T1. And then we're just going to move this value up here, and that's the population size at the next time period relative to T0. So basically, this is the population size at T1. This would be the population size at T2, T3, T4, T5, and so on. And here is a pretty simple calculation where you're just taking this number here and dividing it by that number there. And you're going to do that for all of these all these values here, and the lab manual will talk about what the significance of this calculation right here. What are we trying to get at? Hint: it's a way to measure growth rate, but the lab manual will go into a lot more detail on that. So that's a quick overview of this. If you have questions, again, by all means, you're welcome to come to office hours, ask questions. The instructions are in the lab manual for you, but feel free to review this video, and hopefully that was helpful. Just remember, again, when you're adding births and deaths, just remember these time periods are the exact same time periods all throughout. Just because of formatting, we can't put them all just in one long series here. But when you're adding births, again, for example, at T4, you want to add births that happen here. 1, 2, 3, 4, plus the births here. That'd be 5. That'd be 6. Plus the births here. That would be 7. At T4, for example, and that number would be put in the appropriate place in this table here. Then also the same would be true for the deaths. You want to make sure you're adding the deaths here, plus the deaths here, plus the deaths here for each time period. They're not independent of each other. Okay, so again, if you have questions, come to office hours, read your lab manual. A little bit struggle to get started first, but once you get through it, hopefully the rest of the pre-lab will make sense to you. The lab itself is actually much more straightforward than the pre-lab. But again, the goal of this is showing you a simple model of population growth, keeping tracks of births and deaths. How does that population grow through time, given a certain time period here? And then there's other information here that will be pertinent, again, for other pre-lab questions.